Topographic maps are a tool that geologists would use before the wide availability of color printing or even 3D printing, where you can see the topography of things. So what a topographic map does is use isolines, which are just lines that show points of equivalence. You can use isolines for temperatures, you can use isolines for time zones, and on a contour map, use the isolines of contour lines to show 3D imagery. So if you look at a contour line, you might see just concentric circles and not know quite what it means. But once you're able to read contour lines after this week's activity in PowerPoint, you'd be able to start to visualize a 3D space when you're looking at a contour map. So contour maps take what would otherwise be just flat imagery, and they allow for you to start to visualize in your mind what the 3D space might look like, because you can tell how high something is, how steep a slope is, or even find depressions based off of presence of hash marks, which we'll go into in this week's PowerPoint. So on a contour map, when you do see these lines, each line will represent a given elevation. So that means any point that intersects with that line will have the characteristic of being at that elevation. Any point that is higher or lower on the map would then be indicated by a different contour line. Not all contour lines on a map are going to be numbered. Typically, we just bold and number what's called the index contour. That is similar to how on a clock face you might see just the hours are indicated numerically, because if you were to start to indicate the minutes and the seconds on every clock face, it would be an absolute mess, especially on smaller clocks. So on a contour map, you don't put numbers on every single line. Again, it would be a visual nightmare to have numbers everywhere. Instead, you sort of find your waypoints, and if you're given the contour interval and you know how far of a distance it is from one line to the next, or how different the elevation is from one line to the next, you can use your index contour as reference and then count up or count down accordingly. So when lines are closer together or more bunched together, that'll indicate a steeper slope or a steeper incline. When you have more spread out lines, you're going to have a more gentle slope or more gentle incline. So now this image is included in this week's PowerPoint, and you'll be able to start to play with these differences you see in close together or far apart lines and begin to visualize, is that a steep slope or a gentle slope? And then you'll also be introduced to hasher marks, which let me throw a little bit on here so you can see what those would look like. See, hasher marks are almost like little teeth, or it's like zipper teeth all around the inside of a contour line. When those are present, it indicates a depression in the map, because not everything is going to be mountains and hills. You can have valleys, you can have creeks, you can have craters. So anytime that the land is going to be down from the base level, or it would be the surface level, you start to get depression marks or hasher marks. So with contour lines, you have to start realizing that this is a 2D representation of a 3D characteristic.